For a long while I've been thinking about autonomous agents, pieces of software that runs forever and manages on their own some aspect of a machine. These are the kind of things you would have heard Mark Burgess talk about a lot, and it's different from what we've been doing with orchestration, where a central actor tries to coordinate every step of the machine. I would rather have things that the machine just continues to do on its own. It's got limited applicability, but when it does work for a specific case, it's a very good idea. Let's have a look at an example. I have here a container running. An example container is version 1, and I have a JSON file that describes the version of it. If I want to upgrade, I change the JSON file, and the container got upgraded. You see we have version 2. If I kill it, it'll come back. Give it a few seconds. There we go. So it manages the state, it monitors it, and it also health checks it. So for instance, if all of my containers have their monitoring built into them. So on any container that I have, I can do things like docker exec container validate. And built into the container is everything you need to know about how to monitor it. You don't need to think about how to monitor any of my containers. You just run that, and whatever's inside them will be validated based on the developers who made the image. So I want a piece of software that watches this file. If there's ever a change in this file, it should go into a mode where it deploys what's in the file. It then has to go into a monitoring state where it regularly checks the health of my container, and not on this demo, but perhaps also the remediation state. If the container goes in a bad way, maybe you just redeploy it or something like that. And so we want to integrate this through with anything. I don't want to have you write some Choria extension or anything like this. You can imagine you have a room, you have a HVAC system for your room, and some IoT devices that can monitor the room's air quality. I want this system to be able to query those sensors regularly and upgrade the air quality in the room by turning on the HVAC when required and off again when not. Perhaps you have a small cluster of machines. You have a file that describes the shape of them, how many web servers, how many database servers. You have some health check routines on them. Maybe those are Ansible playbooks or Bolt playbooks, or Bolt plans rather, or Choria playbooks, or anything you have. It doesn't matter what you use. You want a tool that drives calling other tools and making decisions based on the outcomes of those other tools, and you can mix and match any tools you want, etc. So let's have a look at this example over here. I have a YAML file, may not stay a YAML file, today it's a YAML file. The YAML file describes a finite state machine of container manager. So I have a couple of states unknown. I don't know anything about this machine. Starting up, I don't know anything about it. It then has a state deploy, wherein I've learned what should be on this machine or what should be on the machine has changed, and I deploy what should be there. And then it has a state called monitor, wherein I just continuously check the state of the machine. There's a number of transitions or events that the state machine can get. So if it starts from unknown and the manifest is there, it will get absent event, which means the container is absent. That moves it into deploy, and it will then attempt to deploy the version of the container we wish to run. Deploy will trigger a deployed event, which moves it onto monitor, and that can only happen if it's currently in deploy state. If deploy fails, it will just stay in deploy, so it continues to try to deploy forever. If the monitor is unhealthy, in this instance it stays in monitor. You might move into remediation if it's unhealthy. And finally, if the JSON file is missing, it just moves back to unknown. So that describes the phase state machine and all the possible states that my Docker container can be in. And now I have a number of watchers that are valid within certain states. So for instance, here is a file watcher that reads my manif in JSON. And it can do this in any state that the machine is in. So probably I can just remove that line, in fact. And should ever this file change, I will trigger the absent event, which means, call the deploy code, just deploy the version that's in the YAML. If the manifest gets deleted, it will trigger a no manifest event, which moves the machine to an unknown state. I have a watcher called deploy, which is an exec. This watcher can only run when the machine is in the deploy state. It will run every minute. So if the deployment fails, it will retry deploy until it works once a minute. And it just runs the deploy RB. Now this could be a shell, it could be a playbook, it could be Ansible, it could be whatever you use. As long as the thing exits 0 or 1, that's all I care for. If that's successful, you'll see success transition. I fire the deployed event, which will move the machine into monitor state. Now, I have two sets of monitor. I have a short monitor, which every 30 seconds, just do a check, is the container up? And this is the version I want. If it's not, it fires absent, so it'll be fixed. And then every 5 minutes, I do the deep health check, which obviously takes resources and time. And that's it. With this, I have a complete little container manager that can manage pretty much any one of my containers. That follows the pattern where they have this container validate built into there. Let's have a look at some of these things. So, deploy RB. There's some basic preamble. You read the manifest. You just check the thing is fine. Probably this should be in the library. Here I'm just ghetto curling the Docker socket. I should be using the Docker gem, but I'm being lazy. I cycle over all of the containers. Make sure I have the one that I want and make sure it's running. If it's running, I don't have to do anything. If it was running in this wrong version, I kill it, I delete it, and I deploy a new one. Very, very simple. It's 30 lines of code. To health check it, it's pretty much the same preamble. I find my container. If I find it, I call my validate code. If not, I exit one, which will mean monitor is going to fail. And check running, you can guess it's pretty much the same stuff. If I was to pull this into a shared library that I just shares between my Ruby code, these scripts are going to be 5 lines each. And that is it. That is the entire container manager. By just running this thing into my Choria daemon and its autonomous agent feature, I have forever container management. As these things are running, they are publishing events. So let's kill something here. Docker kill. Okay, so it's checked running and that just ran just before I killed it, unfortunately. So it'll be for 30 seconds. But these things are JSON documents that goes into the Choria middleware. They have schemas and so forth. And every state transition will notify a specific document. Every execution will notify. And you can also set it that it should regularly notify the state of some watcher. So here we can see, let's see, the state changed from, no, this is just not the state change. This is an internal of an XX. So it checked it, it ran my check running, and it failed. Now I'm getting a state transition. The state transition that is happening is going to be the absent one, and it moves from monitor to deploy. Now it's running the command deploy. That passed. We have a state transition again, and now it's running monitor and it's running check running, and it will keep doing that. With these events, you can passively monitor any network that runs any of these autonomous agents, and we'll have a Grafana dashboard that feeds into Prometheus that will show you any and all running autonomous agents, their state changes, how frequently they run, all this kind of stuff, how long the executions run. All of this will be shown automatically, and in time we'll have some CLI tools or RPC API endpoints that allows you to download new autonomous agents onto a node, upgrade an existing one, perhaps from a S3 bucket or similar. You should be able to query it, which machines are running, what their current states are. You should be able to stop them, start them, and you should also be able to force a certain state change. So I could force a unknown state change at any point. Because my machine allows that, I would from the RPC call be able to force my machine into unknown if it ever gets into a bad state. Or if I just want to trigger a certain transition that will do something like a schedule maintenance or something along those lines, you just hit this thing, the machine will transition into your schedule maintenance state, and from there you can go through what you need to do. Eventually it will converge back down to your normal running state based on what you design. That's the idea, that's what I'm busy working on. It's quite early days. I think of these things like a very a lo-fi Kubernetes operator, but for basically anything, and that can integrate with all kinds of tools. I'd love to hear from anyone who has ideas about this. Get in contact on Slack or so. Thank you very much.